Now let's look into the basic structure of agents. I'm not going to say this is formalization. It's not a formalism. Actually, ABM does not have a clear formalism. There are some formalism being claimed. However, there is no such dominating formalism in this agent-based model community. Why is that? Because in discrete event simulation model or system dynamics world, patrilineal models, these are all systematically developed. However, these agent-based models have been really emerged by its necessity from the social science or complexity field or physics field. All those fields were using this sort of the concept of agents, and now we know that these can be called an agent-based model. However, there is no single governing formalism in this agent-based model. There are many suggestions, but that could be a good formalism to represent agent-based models. However, doesn't have to be. There are so many other aspects or other formalisms that can be utilized. Having said that, let's look into at least the basic structure of agents. Agents have some characteristics that researchers agree upon that agents have. So agents have 1, perception, 2, decision making, and 3, action. These three aspects are critical. First, it should be able to perceive outside stimuli, and based upon its own state and outside stimuli, decision making should be feasible, and finally act upon the outside world so that my behavior can be others outside stimuli. Okay? And having said that, by saying these actions and perception, we implicitly assuming the existence of space. Right. And now, the agent. Agent, as I said, an entity to have an capable of action defined by an agency, an intelligent agent, smart decision making, autonomous agent, decision making on its own. However, I want to focus upon this terminology here, bounded rational agents. There are some virtues, there are some characteristics of the agent, and agents are bounded rational agents, which means that this boundedness, meaning that given this environment, given the environment or space, there is a locality of the agent, so that given this locality, agents can perceive this much of the space, not the entire whole, right? As a human being, I can recognize what's happening around here. However, I cannot understand, I cannot comprehend or perceive what is happening, like the events in other cities right now, right? So that this is a limited space perception, limited environment perception, and meaning that agents are not omniscient. Okay? Omniscient means that omni is a one word. Omni is one word, and shunt is something else. I-E-N-T. Omni means that like everything. I can govern everything, like every part of this world, or like the whole, right? So omni means like that. And shunt means that recognition. Conscience means what? In Korean, 의식. So conscience means that I can perceive something, right? I have my own 의식, right? The capability of thinking, or capability of recognizing something. And omniscient means that I can recognize everything right now at this moment across the environment. that is the only virtual, like what? God, right? So that individuals living in this either in real world or virtual world is going to be a bounded, at best, rational agent. And now let's turn our focus to the diagram. So agents' key characteristics were perception, decision-making, and action. And implicitly assuming the space and environment. Here, space and environment provides an event. It's like a depth formalism, right? Provide an event, and there is a sensory input, right? And then sensory input will invoke the awareness of the situation, right? And now we have a condition action rule. And awareness, for example, like the state, and condition action rule will come together, will choose an action, decision making. And then our actuator, what agents can do to the physically or cyberspatially or through the social interaction, what it can do and act upon it. So this is a simple reflex agent concept. Okay. It's going to be reflex. Why is that? Because it is not thinking the future, it just reacts upon what it perceives. Like good person wouldn't do that because that perceives some event and think it through and also expect what would be world will look like or our surroundings will look like or our friends, family will look like, how they would behave upon our actions, think it through, and then act, right? So that this doesn't involve such kind of expectations or thinking. So it is just saying that simple reflex agent. Of course, this is a basic structure of the agent, and then it can be improved further. So if we go beyond the simple reflex agent, these are some suggestions, such kind of simple reflex, the further advanced structure of the simple reflex agent. So for example, let's imagine that we perceive an event through the sensory input, and during creating the awareness, we have a state, right? And the state is going to be inferred and estimate the future change, okay? And estimate its own action, and then together create what will happen, and then update the state. So there is a feedback loop going, okay? And eventually, once the state would not change any further, then according to that state, actions to be done will be selected by the state and condition action rules, and actuator is here, then actions is going out. Okay? So this is one way of thinking through our actions. Okay? So for each time step, it's not just reacting to its behavior loop, but rather it's expecting the future, and so forth. Even further, what we can do here is that, okay, so get the event and then update the states, okay, by the event, so that this is what? This is the delta transition rule, right? And future change estimation, agents' actions are being considered, and together there is an update feedback loop is going. And afterwards, for each of these potential actions, per actions utility calculation is done. I'm not going to teach this in this course. This is outside scope, out of the scope of the simulation class. But rather, I want just briefly introduce that this is being called what? Pi policy function. And pi action will be selected by the given S. And this is going to be covered by what? Some reinforcement learning class, RL class, should be able to model these detailed reactions. So there is a role separation. Simulationist creates this whole framework and virtual world setup, and inside of these agents thinking machine, we are going to have the RL mechanism and models inside of the agent so that it can select its own actions autonomously. And to do that, some utility definition or reward definition will be needed, and best utility action will be selected and actuated. Okay, so then even simple reflex agents can grow further and further and further inside and include the RL component here, so that agents can be very complex or can be very simple, like the simple reflex agent. It's up to your choice. But rather, agent-based model does not being bothered by the complexity within inside of the agent's decision-making, but rather it will be more concerned about the agent-to-agent, agent-to-environment, those interactions and complexity coming out of those interactions.